Okay, we've now got the sampling logic figured out. Let's go ahead and examine and clean the data. This is a fairly familiar process to us. We'll start by eyeballing the data by plotting it. This we will do in this instance making use of the sns.regplot function. This is from the Seaborn library. We go ahead and display this to screen, and right away we can see that there are a whole bunch of trips where the trip distance is 0 but where the fare amount is quite large. We also have a number of trips where the trip distance is greater than 0 but the fare amount is 0. Both of these represent sets of points that we need to clean up. If we read the comments in the code provided by Google, we can see that this can be easily accomplished by filtering out all data where the trips are 0 in length or where the fare amount is less than the minimum cab fare of $2.50. So we go ahead and add those additional where clauses into our query. Let's go ahead and rerun our query to exclude these data points, the ones that we don't want, and then let's once again plot the resulting data set. We find that we have eliminated the two erroneous sets of data points we just referred to, but there is yet another strange set of data points which capture our attention. We can see that there are a large number of trips where the fare amount is exactly equal to $45 or $50. But in this case, we do not actually exclude those because both of those sets of points make sense. Those represent the fixed amount rides from the two airports that service New York City, JFK and LaGuardia, anywhere into Manhattan. Because these are legitimate rides, we don't do anything about these data points, we leave them as is. But these trips, which represent journeys into Manhattan from the outer boroughs, also make us wonder whether toll amounts are properly captured in the total amount. So let's go ahead and sample some of the data. Let's go ahead and examine some of those data points where the toll amount is greater than 0. Let's do this and just eyeball the data contained in the toll amount column as well as in the total amount column. We can see here two interesting things. We can see that the toll amount and the fare amount are both non-zero. That's the first interesting thing. The second is that the total fare amount is considerably larger than the sum of the tolls and the fare. What accounts for that difference? To be clear about what I mean, let's consider the first row. The toll amount there is $4.8, the fare amount there is $52, but the total amount paid was $67.7. So what accounts for the difference between $56.8 and $67.7? The answer, if you've already guessed it, is the tip. It turns out, however, that the handling of the tip amount is rather inconsistent. If the tip was paid in cash, that tip is not going to be reflected in our dataset. On the other hand, if the tip was paid using a credit card, then the tip amount is indeed reflected. In order to eliminate any aberrations or strange distortions introduced by this inconsistent behavior as far as tips go, we will go ahead and ignore the tips entirely. We will simply recalculate the total fare amount as the sum of the fare amount and the tolls. This will have the effect of eliminating all tips from all data points in our dataset. Because we are dealing with pandas data frames, we can make use of the describe method on our trips data frame to get a quick summary of the statistical properties of each of the columns. When we do this, we can see that we have 11,400 data points. We also get a sense of the mean, standard deviation, min, max, and the 25th and 75th percentiles. So all of our data points are whole. We have 11,400 values in every data point, so that's a good sign. We do, however, notice something a little odd. We have an outlier problem in the longitudes. For instance, if we look at the minimum and the maximum longitudes, we can find that these are very far indeed from the mean. The mean of both the pickup and the drop-off longitude are just about 72. In just a moment, we are going to clean our data and exclude all data points which lie outside a bounding rectangle. But before we get to that, let's just eyeball our data a little more. Let's write a function which will sample data points within our data and plot their starting latitudes and longitudes on a graph. This is the show rides method, which you can see now on screen. This isn't particularly complex, but it's going to go ahead and print a graph. This graph will take in 10 trips and it will plot the start and end points of those trips. Let's take a moment to digest what this graph is trying to tell us. On the x-axis is the latitude and on the y-axis is the longitude. Every one of the lines that we see represents one trip. The start and end points of that trip are represented in terms of the starting and ending latitudes and longitudes. A very long line indicates a long trip. The very short lines represent short trips. Let's go ahead and perform the same exercise, this time for trips which did involve a toll. When we do so, we find that the trips that do involve a toll are much longer than those that do not. And that is something that we would expect. It's a good sign. It means that the toll column is probably accurate and can be relied on.